All right, so the first one, as a recap, okay, we are subtracting. What is our final answer? Jax?
I don't know this, but I got, what's the top one?
Mm-hmm.
I got 3x to the third plus 2x to the second. No, 6x minus 3.
Perfect. Good. Good. How many of you did get that? Good. Remember to distribute the negative all the way through. Okay, for the second one, 6x squared minus 17x plus 5. What is our factored form? Yeah, Katie. Good. How many of you did get that? Okay, remember, since you have a leading coefficient other than 1, you have to multiply a times c, which is 30. What multiplies to 30 but adds to negative 17? It was negative 15x, 2x, plus 5. And when you split the middle, greatest common factor of the first two is 3x. You're left with 2x minus 5. Greatest common factor of the next two is negative 1, 2x minus 5. You group together your outside, 3x minus 1 and 2x minus 5. All right. And x to the fourth minus 16. How do we factor it? Kip. Perfect. Excellent. Okay. So it's x to the fourth, so it's just doubled. Okay, our difference of two squares. So you first have x squared minus 4, x squared plus 4. But then we have, again, difference of two squares, which we could keep going. Okay. Excellent. Good. How many of you did get that one? All right. Now, yes, Kate? Yep. You wouldn't solve it. Yep. Only if it's set equal to 0. Or if it says solve. So show all your work as you solve the polynomial. So here, what were our solutions? David? Good. Negative 1, 0, and 3. What's the greatest common factor? Yep. David? 4 what? 4x. And you're left with x squared minus 2x minus 3. Then we have 4x, x minus 3, and x plus 1. Everywhere you see an x, you set equal to 0. So we have x equals 0, 3, and negative 1. That also confirms because what is our degree? 3. So therefore, how many solutions should we have? 3. Perfect. All right. And then this guy here, which is where we left off, okay, before break. All right, so you want to list the zeros, which are your x-intercepts. What do we see on the graph? What are they? Let's go, you guys. Same people. They're answering. Yep, Eliza. Negative 4, negative 2, and what else? 1. Perfect. Good. Is this degree odd or even? Kip, how can you tell? Good. Okay. Besides the curves that you see in the middle, it's in the direction of like a linear function. Okay. Is the leading coefficient positive or negative? Yep. It is positive. As you read it left to right, it is increasing. So what is our relative maximum? So what is our maximum here? Good estimate. What would we say? Yeah. It would be 4. Y equals 4. This is your maximum. And what is your minimum, roughly? Yep.
Y equals -8.
Yep. Y equals -8. All right. Now the end behavior. Be careful. Look underneath. Okay? It's different as x approaches positive infinity. So now we're looking this way. As x increases, where's my y heading to? Yeah. Infinity, good. As x approaches negative infinity, where is y heading to? Yep. Negative infinity, good. Okay, so when you're doing end behavior, you want to make sure you pay attention to what's underneath the limit. Okay? Sometimes it gives you negative infinity first, sometimes it gives you positive, so we have to be careful. Okay? Any questions? Before break, we started to look at the practice. Okay, we didn't get very far. We did number 6. We did this one together by tying it all together. But if you look at pages 5 through 7, okay, as a little recap, pages 5 through 7 in your packet. Let's see how far. As a little recap, we'll do a few of these together. Some of you already have it written down. Okay. So, looking at on page 5, what is the degree of this first polynomial? 4. Is that odd or even? Good. Leading coefficient. 1. Leading coefficient is 1, and it's positive. It's the number attached to the degree. Okay. Then, number of turning points, which is what? How do we determine? What was it? 3. It's 1 less than the degree. 1 less than the degree. So if this is even and a positive leading coefficient, is it going to resemble a line or a parabola, which is a quadratic? Yeah. Parabola facing up. So your end behavior, will it be the same or different? Yeah, Catherine. Same. And where is it heading? Positive infinity. Good. Excellent. So as we go through this, make sure you're checking. Now for B, what is our degree? Yeah, Kaden. 3, which is odd. Leading coefficient, positive or negative? Kaylin? Negative. Okay. Number of turning points. Jax? 2. Good. Now, end behavior. Is this going to resemble a parabola or a line? Line. Increasing or decreasing line? Decreasing. So we'll look something like that. Okay. So as x approaches negative infinity, where is y heading? So as x gets smaller by moving to the left, where are we going? Yeah, it's infinity. Good. As x gets larger, where is y going? Yeah, it's good. Okay. And then the last one here. What is the degree? 6. Odd or even? Even. Okay. Leading coefficient would be what? David? -2. How many turning points? Yep. 5. Okay. Line or a parabola? Yeah. Parabola. And is it both arrows pointing up or both arrows pointing down? Good. Good. Negative. Good. All right. And then part 3, finding the zeros or the solutions. So basically, everywhere you see an x, you're setting equal to 0. So number 1, what's my solution? What would it be? Yeah, Ryder. 5. X minus 5 cubed, set equal to 0. When you take the cube root, which anything root of 0 is 0, x equals 5. How about number 2? Campbell? 0 and 8. Good. Number 3. Yep, Charlie. 2 and negative 7. Okay. All right, number 4, what would it be? Eliza? Perfect. Good. Now, number 5 and 6, you had to factor, okay, in order to find the zeros, okay? So x squared plus 7x plus 6, how do I factor it? Kate?
Oh, how you factor it? C split multiplies the 7.
Which is?
6
X plus 6, X plus 1. So your two zeros are negative 6 and negative 1, okay? For 6, what do you have to do first? Yep.
Would you have to split it down the middle and then
Yep.
do it that way?
Yep. Split down the middle. Greatest common factor of the first two is x squared. We have x minus 3. Greatest common factor of the next two. So we have factored form x squared plus 1 and x minus 3. So what are your zeros? What are your solutions? Yep, right there.
Plus and minus 1.
Careful. 3 is right. Careful, Charlie. Plus or minus I. Because we have x squared plus 1 equals 0. Negative 1. When you take the square root, automatically plus or minus square root of negative 1 is I. Okay? So now, this is where the multiplicity comes in. And the changes to the graph. Okay? If it's an odd degree, if the factor is raised to an odd degree, what happens? Who remembers? So for example, let's look at number 2. We know our zeros are 0 and 8, like we just found before, solutions. So at 0, what are we doing? Touching, bouncing off the x-axis, or crossing? Crossing, because x is to the first exponent, which is odd. Okay? X minus 8 squared, since it has a multiplicity of 2, what is happening? If 0 crosses, therefore 8 is going to touch because of the multiplicity of 2. So if it's an even multiplicity, it's touching. So 2 and 4. If it's odd, it's crossing. Okay? So for example, for number 3, we have 2 and negative 7. They're both going to do what? Cross. Good. All right. And then number 4 are zeros from before, which we saw. At negative 5 halves, what's happening? What's happening at negative 5 halves? Grant. Negative 5 has, so 2x plus 5 has an exponent of what? 1. So what would it do? Look at the other examples we've done. It would cross. Okay. At 3, Tommy, what would happen? It would touch. Good. Because it has an exponent of 2. Then for number 5, this was negative 6 and negative 1. Both of them would do what? Both of them would do what? Nick. Careful. It would cross because you have x plus 6, x plus 1 is factored form. They both have an exponent of 1, so it crosses. Yep.
I'm really confused about how, like, the exponent didn't have an exponent.
Go back to our notes. When a factor x minus k of a function is raised to an odd power, so example, x plus 8, x minus 4, or x minus 2. Those are types of examples where they're raised to the first exponent. Okay? That's when they cross the x-axis. So if you look at this example at negative 3 and negative 2, crosses. Okay? When you have a factor raised to an even power, so x plus 2 squared or just x squared, it touches or bounces off. So this is x plus 6 squared at negative 6. It bounces off the x-axis. Okay? So it all depends on the factor exponent. All right. But number 6, we have 3, but our 0 is plus or minus I. At 3, we are crossing. But can we see plus or minus I? No, so it's not doing neither. Okay? Okay, this is all recap before break. Then if we look, we'll just do one of these. At number 1, a polynomial has an odd degree and a negative leading coefficient. It has an x-intercept at 5 with a multiplicity of 2, and x-intercept at negative 3 with a multiplicity of 1. Okay? So how would you write an x-intercept at 5 as a factor? Yep.
X minus 5.
Yep. X minus 5 is the factor that represents x-intercept at 5. But since it has a multiplicity of 2, I'm going to tack on the exponent. Okay, multiplicity of 2 is the exponent. Okay, x-intercept at negative 3 would look like what as a factor? Jaden? X plus 3. But it has a multiplicity of 1, which would have the 1 there. You don't have to put that, obviously. Okay. What else do I need to include? I have my factors and multiplicity. What else? Jax?
We could have put, like a negative sign.
Perfect. A negative sign in front. So if I was to sketch this, here's negative 3, here's 5, a rough sketch. Okay. It's an odd degree, so it's going to resemble a line, negative line. Okay. Rough sketch, we are crossing at negative 3 and then bouncing at 5. Okay, so this is where it touches, this is where it crosses. Okay. If you haven't done so yet, and I know the graph for number 3 got a little mixed up, so just write your XY plane there. Try 2 and 3 if you haven't done so already. All right, looking at number 2, what would my equation be in factored form? Eliza? Excellent. Perfect. And this is an even degree because if we look at the exponents, okay, we have a degree of 4 and a positive leading coefficient. So at -4 and 1, at both -4 and 1, what's happening? Catherine? They touch. Good. Touch, touch, and it's a positive. So both arrows will be pointing up. So a rough sketch will look like that. Okay? Now for number 3, a polynomial has an odd degree and a positive leading coefficient. X-intercept at -2. Okay? With a multiplicity of 1, x-intercept of 7 with a multiplicity of 2. So what would this look like? Yep, Riley. Mm-hmm. Perfect. Okay, so -2 and 7. So at -2, what's happening? Okay. Crossing at 7, what is happening? Yep. Perfect, good. And again, it's going to resemble a line, okay, because it's not a degree. So we cross at -2, touch at 7. Okay, and again, these are rough sketches. All right, so we just looked at, okay, going through a little bit of everything that we learned before break. Okay, it seems like many moons ago. Okay, but what we're going to look at now is if you turn to 2.9 practice 2, we're going to use your graphing calculator, so take those out. This is on page 9. Okay, your midterm review packets can also be put away. They don't need those right now. Okay. Yep. The only time we're going to really need our graphing calculators to find the exact max and mins. Okay, so right now, what I want you to do to recap is degree and name of that function, factored form, find the y-intercept, x-intercepts, and the end behavior. Okay, these are the 5 things I want you to do right now. Okay, because you know how to do those already, based off of x squared plus 6x plus 5. All right, go ahead. Okay, what is the degree and name? What's our degree? Kate? Yep. Careful. No. Riley? Quadratic. Okay, that's all right. Okay, it's a degree of 2, and it's a quadratic. What is factored form? Yeah. Good. X plus 5, x plus 1. What is the y-intercept? Yep. Yes? 0, 5. Anytime you have to find the y-intercept, 7x equals 0. Okay? What are my x-intercepts? Charlie? -5, 0, -1, 0. So those 3 points, this graph is not great. -1, and then 0, 5. Okay. So knowing that it's a quadratic, which is an even degree, positive leading coefficient, what is my end behavior? Yep. Infinity for both. Perfect. Okay. So now, we're going to find to see if there's an exact max and exact min. So in your calculators, okay, in your calculators, let's make sure everyone's at the same spot. So we want to clear. So go to second, plus sign, 7, 1, 2. What it does is resets everyone so we're at the same point. You will have to do this also before and after your exam. Okay? You're resetting your memory. So if we go into y equals, which is above the second key, all right, we're going to type in our function x squared plus 6x plus 5. So the x is below the mode key. The squared is above the log key. Or you could use a little caret here. Plus 6x plus 5. Okay. Then if we hit graph, we're entering x squared plus 6x plus 5. Okay, this is what we should see. Right now, we already know our 2x intercepts and our y-intercept. We know that. We just found that algebraically. Okay. Now, to find, do we have a max or min here? Anybody? We have a minimum. Okay, so to find the exact, there's 2 ways to do this. The easiest way, use your x-intercepts to help you. Okay, we know the minimums here, which is between those 2 x-intercepts. Okay, so to find the minimum, go to second, trace, which brings you up to the calculate screen. You have to make sure you press second first. Then we go to number 3, the minimum. Okay, so one way I'm going to show you, where it says left bound at the bottom of your screen, you're going to choose the x value to the left of that minimum. So I'm going to use my -5 here. So all I'm going to do is type in -5, hit enter. Then it says right bound. I'm going to type in my right x-intercept, or an x value to the right of that minimum, which is -1. Then it says guess. You're not done yet. Hit enter. You're done when it says minimum. Okay? So your minimum, I'm going to write on the board so we don't forget, is -3, -4. Okay? -2.99994 is -3. Okay? That is one way to find the minimum. Some of you will figure out very quickly another way how to do it. Another way to find the minimum, go to second, trace, number 3, where it says left bound. If you move your cursor slightly to the left, hit enter, it gets that point. Then it says to the right, move your cursor to the right of the curve, hit enter, then hit enter again until it says minimum. You get the same thing. Okay, so this way that I just showed you, the second way, is what I used to do. But using the x values to the left and to the right of the curve is easier. Or whatever way you choose. Showed you both ways. Okay, so it's totally up to you. Both ways will get the same answer. Okay, so your minimum, where is it? Your minimum is -3, -4. And I'm putting the point for a reason, okay? -3, -4. It's roughly here. Okay, here's your curve, okay? So looking at your curve, we can now, or your graph, where am I increasing? This is now going back to functions. We're bringing functions back. Where am I increasing? Jax?
-3.
Good. -3, infinity. That's why I use the point instead of just the y value, because you need it for increasing and decreasing. Where am I decreasing? Jax?
-.
Perfect. Good job. And then the next two are positive and negative. What are my intervals of positive? Where am I positive? Campbell? Hmm? Perfect. Excellent for remembering the U. Good job. Where am I negative? Yeah, Kaden. Good. Okay. Does this graph touch, like bounce off the x-axis at all? Does it cross? Where? Yep.
-5
Good. -5 and -1. What is my domain? Charlie? Good. What is my range? -4 to infinity. -4 has a bracket. Okay. Now, what is the degree of this function? Is it, what's our degree? 2. How many times does it change direction? Once. Good. Is the degree even or odd? Even. Is the end behavior same or different? Same. Good. Okay. So what we did right now is we graphed our knowledge of polynomials, plus we brought back in functions. Okay? Yep. Only when it touches or crosses is where the x-intercepts are. Okay? And when it touches the x-axis. All right? So we're going to try a few more. All right? So for this next one, I want you guys to degree name, factored form, y-intercept, x-intercept, and behavior. We'll do the max and min together. Go ahead. All right. What is my degree and name? David? Cubic. Perfect. What is factored form? Riley? Careful. Careful with your signs. Nick? Okay, when you split the middle, that's what you get. But is it fully factored? Yeah. Good. Remember, difference of two squares. Okay. What is my y-intercept? Yeah, Tommy. 0, -3. What are my x-intercepts? Christian, what are my x-intercepts? Good. Okay, so those I'm just going to plot right here. 0.0, -3. All right, what is my end behavior? As x approaches negative infinity, where is y heading? Negative. And the other one would be where? Eliza? Positive. Okay. So now we're going to enter this guy. You could do factored form as well in our calculators to find the max or min. Okay, so let's go to our calculators. Y equals, clear it out. All right, x, I'm going to do the little caret here for 3, and then press the right arrow. So x cubed plus 3x squared minus x minus 3. And press graph.
Can you go a little bit slower?
Okay, x is below the mode key, and below the clear key is the little exponent, 3. Press the right arrow, then plus 3x squared is right above the log key, minus x minus 3. And then press graph. Okay, so here we have both max and min. Okay, so we're going to do this either way you choose. I'm going to use my x-intercepts for both. So, second trace. Number 4, we're going to do the maximum first. Line. Okay. For my maximum, the left bound, I'm going to choose -3. Hit enter. The right bound, I'm going to use -1. Enter. Where it says guess, I'm going to hit enter again. So my maximum, and we're rounding to the hundredths. Okay. So my maximum, -2.15 and 3.08. Okay. And we're finding the exact. So even though our minimum looks like 0, -3, we're going to find the exact. So go to second trace, second trace, second trace. Still on vacation, I think. Okay, you guys do this right now. Second trace and press minimum. Okay, totally up to you. You could do the x-intercepts. If you do the x-intercepts, the left one, I would use -1. The right one, I would use +1. Okay. There it is. Okay, so my minimum. Did you guys get the same thing? Those of you that did it? -3.08. Okay, so I'm going to jot those down. My maximum. Okay, plot those points. And again, just a sketch. Okay, so now using that information that we have, where am I increasing? And you have to use the x values that you wrote. Okay, where am I increasing? Jax?
Well, like negative increase negative 2, then 0 is going to decrease. So like a U kind of.
Yep, I'm using the exact x values that I have from, but thank you for answering. Appreciate it. Okay, the exact values you have written. And I'm decreasing from negative 2.15. Okay. Where am I positive? Positive and negative, you use your x-intercepts. So where am I positive? Noella, where am I positive? It's okay. Perfect. Good. Okay. Where am I negative? See, James, where am I negative? Careful. But you should have this, and you should have the graph here. Negative infinity, -3. Okay. And -1 to 1. Okay. Okay, it doesn't touch the x-axis, meaning bouncing off, but it does cross. Okay. It does cross -3, -1, and 1. What is my domain and range? Zoe, what's my domain and range? Good. They both are the same. Okay. What is the degree of the polynomial? Kaden. 3. How many times does it change direction? 2. Okay. Is the degree of even or odd? Odd. Nick, can you grab that for me? Thank you. Are the M behaviors same or different? Different. Okay. So we just went through 2 examples, okay, of fully finding our max and mins, okay, then increasing, decreasing, constant, well, not constant, increasing, decreasing, positive, negative, touch, cross, domain, and range, okay? So what I want you to do in class right now is to work on 3 and 4, okay, in class, okay? So number 3 and number 4 of this practice, okay? 3 and 4. Okay, your homework will be 2.9 practice 2. Okay, and I'll put the page numbers on there shortly. All right, so right now in class, I want you to work on 3 and 4. Okay, do the best you can without a calculator, someone who has one. If you need to, one of you do 3, finding the max or mins, and then the other person try it out for the second problem, max and mins. Okay. Those are for those that don't have a calculator.